Consider the following massless board resting on a fulcrum. A force of 375 newtons is applied downward at a distance of 2.54 meters to the right of the fulcrum. The torque from force 1 is 952 newton meters clockwise. Force 2 is 216 newtons and it must create a torque of 952 newton meters counterclockwise. What must distance 2 be? So let's label this diagram. Force 1 is 375 newtons downward. Force 2 is 216 newtons downward. The distance 1 is 2.54 meters, and distance 2 is what we have to find. So we can use the torque formula to figure out distance 2. So we know that torque is equal to the perpendicular distance times the applied force, and we know that the torque from force 1 must equal the torque from force 2, so torque 1 must equal torque 2, or in other words, torque 1 plus torque 2 must equal 0. So torque 1 is R perpendicular times F1, torque 2 is R perpendicular times F2. So distance 1 is 2.54 and force 1 is 375 newtons. And this must equal distance 2, which we do not know yet, times force 2, which is 216 newtons. So 2.54 times 375 is 952.5, and this is equal to 216 times the distance 2, so times 216. So we can divide both sides of the equation by 216 to simplify for distance 2, and we get distance 2 is equal to 4.41 meters. The second part of this question asks, if the two forces are pushing down, what is the magnitude and direction of the force which the fulcrum must exert to keep the board in static equilibrium? Static equilibrium means that there is no movement at all. So what is the force that the fulcrum must exert on the board so that the whole system does not have any movement? So the force of the fulcrum, so let's redraw the drawing roughly. So this is the fulcrum and these are the two forces that are acting on it. And so if these two forces are acting downward on it, the fulcrum must apply an equivalent amount of force in the opposite direction for there to be static equilibrium. So force 1, force 2, and then this is the force of the fulcrum. So the force of the fulcrum must equal force 1 plus force 2. So force 1 is 375 and force 2 is 216. So the force that the fulcrum must apply is 591 newtons, and the direction in which it must apply this force is upwards.